So I've been asked for some help with the titration calculations, and here I'm going to use question 3 that you had on your sheet and work through using the calculations map that I gave you in class. So the first step is to identify known and unknown substances in the question. So normally I might underline the known substance and circle the unknown. So if we have a look in the question here, in a titration between potassium hydroxide hydrochloric acid, 10 centimetres cubed of 0.1 mole potassium hydroxide, this is our known quantity, is neutralised by 0.12 moles per dm cubed of hydrochloric acid. So we also know something about the hydrochloric acid, and what we've been asked to do is calculate the volume of hydrochloric acid. This is our unknown. So doing this first step kind of helps us to see clearly about what it is that's going on. So the second step is to calculate the moles of the known substance. So in this question we're calculating the moles of potassium hydroxide. Now we have a concentration and a volume, if you look back to the question. So we know that we can work out the number of moles by multiplying the concentration by the volume. So if we put the numbers in from the question, we see that we have 0.1 moles per dm cubed, and with the volume, this is given to us in centimetres cubed. So we have to change that to decimeters cubed. Now, to make sure that you get this the right way round, sometimes it is worth writing it down. Let's go from centimetres cubed to decimeters cubed. We see that number is getting 1,000 times smaller, so we need to divide by 1,000. If we were going from decimeters cubed to centimetres cubed, we can see that the number is getting 1,000 times bigger, so we would multiply by 1,000. In this case we have 10 centimetres cubed, so we divide that by 1,000, and that will give us 1 times 10 to the minus 2 moles, or 0.01. We can put that straight in. And when we do the calculation, 0.1 times 0.01, we get 0.001, or 1 times 10 to the minus 3. And not forgetting that this is the moles of potassium hydroxide. So our next step is to look at the mole relationship between the known, which is potassium hydroxide, and what we're ultimately trying to calculate, which is hydrochloric acid. And here we see from the equation that 1 mole of potassium hydroxide reacts with 1 mole of hydrochloric acid. This makes the next step nice and easy, but it's not always the case. So if we go back, our next step is to calculate the moles of the unknown. And if we go back, we see that we have 1 times 10 to the minus 3 moles of the known, and 1 mole of the known reacts with 1 mole of hydrochloric acid. Therefore, 1 times 10 to the minus 3 moles of KOH will react with 1 times 10 to the minus 3 moles of HCl. And our last step now is to calculate the unknown quantity. So if we go back to the original question, we're trying to calculate the volume of hydrochloric acid. and we know that the concentration here is 0.12 moles. So you can use the triangle if you like, or rearrange the original equation, but we calculate the volume by taking the number of moles divided by the concentration. So putting that into the calculator, we end up with 0.0083, and this is in decimeters cubed. So if we flip back to how we convert from decimeters cubed to centimeters cubed, we multiply by 1000, which here gives us 8.3 centimeters cubed. And we see from the answer sheet here this is correct. I'm not sure where they've got the second 3 from. When I did the calculation, that came out as 8.3 exactly. But it's close. So if we have a look at the work that you've sent me, you have actually done this problem properly. You just haven't done it the long-winded way, which is fine. It's absolutely fine. But I'll show you where you have gone through the process. So here you have correctly identified the volume and the concentration of sodium hydroxide here, so the volume and the concentration here, and you have also converted a centimeters cubed to decimeters cubed, so that's correct. And you've calculated the moles of the sodium hydroxide here, which is step 2. You've used the mole relationship, so 1:1. Again, whether you're aware of that or not, when it's 1:1, it's fairly straightforward, because you've recognised that this now gives you the number of moles of the hydrochloric acid here. So you've used this and you've calculated the moles of the known, which is here. And then what you've done is, using your formula up here, you've got the number of moles, which you've worked out. You've got the volume given in the question, so moles divided by volume, which is what you've actually done here, remembering of course to change the decimeters cubed to centimeters cubed to work out the concentration, which you've given the absolute correct units of, which is what's been asked in the question. And if we flip back to the answer book, you see that you have got the correct answer here. So the point I'm trying to make here, this is the long method, which will take you through virtually any chemical calculation. Here, you've done it in a shortened way, which is fine, which is understanding. My only point I would caution you is you need to make sure this will work. You need to make sure you're understanding that if the mole relationship is not 1:1, that you might need to do some tweaking of your calculation, but this is absolutely fine. If you need to know how to do the tweaking, the calculation, look at the other Show Me I've done on titration calculations. But well done, keep going, have a go at some of the other problems on the sheet.